In this lesson, we will be finding the surface area of pyramids and cones. Surface area includes lateral area, which is the triangles, and then surface area includes all the triangles plus whatever the base is. If you look at your formula chart, these are surface area. Surface area just means area of the surfaces. Oops, it doesn't like the shiny part. So we are going to do, sorry, it doesn't like the shiny of it. So we're going to do lateral area of prism or of pyramids and of cones. So notice they're here. So we have lateral area, and then we have total surface area. So when we say surface area, we mean total. All of them are area of the surfaces, but we've got lateral area, and then we've got surface area or total surface area. So the lateral area of a pyramid is 1/2 PL. So L is new, so we'll talk about that. And then surface area is the lateral area, 1/2 PL, plus B. Now, I want you to understand what everything is, right? This is your 4 triangles. So these are all your triangles. And then this takes the triangles, right? Plus it adds, in this case, the rectangle. So that way you can recognize, sometimes you may not need to paint the bottom of it. And so you need to recognize when you're going to use lateral area and when you're going to use total surface area, of the area of all of the surfaces. You can't always use the formulas. Sometimes you have to use what you know about the shape and just break it into pieces, right? Sometimes you know this is triangles and rectangles or triangles and squares. Your slant height is this piece right here. This is the new part, and it's just how long the slanted is. You've got your height, that's how tall it is, that's how tall it stands. Remember, we don't lean over when we're measuring our height, we stand up straight. So the height is how tall the pyramid stands. The slant height is how tall the triangle would stand if the triangle was standing up. Okay, but it's leaning over. So let's look at this problem. So I want lateral area, I want surface area. So lateral area is 1/2 the perimeter times the slant height. That tells you what you need to know. And then your total surface area is your lateral area plus the area of the base. That means you need to go find the perimeter of the base and the area of the base. The base is always going to be the side that is across from or not touching the apex. Remember, this is your apex. And so that base is that yellow piece that's not touching the apex. So we have our pyramid height. I'm just going to label all my pieces. My height of my pyramid is right there. My slant height is right here. That's 13. And my base edge is 24. Now, I do want to make a point. This formula works for regular pyramids, not all pyramids, only regular pyramids. Remember that regular means that all of the sides are the same length. So then I need to go over here and I need to find my perimeter. Well, these are regular, these 3 are, this one is not. And so we'll talk about what to do with it. So first let's find our perimeter. It's 24 plus 24 plus 24 plus 24. So it's 24 times 4, that is 96. And then the area of the base, so the base is a square. So that would be length times width, or base times height. So that would be 576. So we would plug it in. So it's 1/2 the perimeter of the base, which is 96, times the slant height, which is 13. So 1/2, or 96 times 13 divided by 2, or 1/2 times 96 times 13 is 624 meters squared. So we can take that 624 meters squared and we can add the area of the bottom. So what I just found was the 4 triangles, right? I found the 4 triangles. So now I'm going to do the 4 triangles plus the yellow square. So that was 576, so 624 plus 576 is 1,200 meters squared. Now, triangular prisms or pyramids are kind of hard to see. So what you want to do is kind of, if you start, here's your apex. So you can see the triangles that form it. And so highlight this bottom triangle. It'll really help it pop out so that you can see your base. Lateral area, I know that I need 1/2 the perimeter of the base times the slant height. Surface area, I need 1/2 the perimeter of the base times the slant height plus the area of the base. This time the area of the base is a triangle, so we have to find that. So the perimeter of the base, the perimeter of the yellow triangle, is 10 plus 10 plus 10. So the perimeter is 30. The area of the base is a triangle, so just focus on the triangle for a second. The base of the triangle is 10. The height of the triangle is 8.7. So 1/2 times 10 times 8.7 is 43.5. Now we have everything we need to fill in our formulas. So my lateral area is 1/2 the perimeter of the base times the slant height. In this case, your slant height is right here. It's on that slant. It slants from your apex down to the side. That's what you're going to look for that slant height. And it is 6.7. So 1/2 times 30 times 6.7, or 30 times 6.7 divided by 2 is 100.5, and that is inches squared. Now I want to find my total surface area. I found my lateral area. That was 100.5. I'm going to add the area of the base. The area of the base was 43.5. So I add those two numbers together and I get 144 inches squared. Okay, now I have another pyramid, right? We have this apex. It is a pyramid, so make sure you look up the right formula. 1/2 the perimeter of the base times the slant height. And then the same thing, we need our lateral area, which is all of our triangles, right? This is all of our triangles, and then this is adding all of those triangles plus the pentagon. Okay, so we're going to add the area of the base. So my base is anything that isn't touching that point. So it is this figure right here. So take a break for just a second, deal with just the yellow. So the perimeter of the base is 4 plus 4 plus 4 plus 4 plus 4. So 4 times 5, right? 5 sides, it's a pentagon, is 20. And then the area of the base that's a regular polygon, so it's 1/2 AP. Got that from the formula chart, 1/2 AP. So we do 1/2 times 2.75 times 20, and we get 27.5. Now we can plug in everything we need. So we have 1/2, the perimeter of the base is 20, times the slant height goes from the apex to the side, so that's 9. So 1/2 times 20 times 9 is 90, or half of 180 is 90. And then we're going to take that 90 that we originally had, and we're going to add the area of the base, which we found to be 27.5, and we get 117.5, and that is, oh, I forgot, that's square yards and square yards, or yards squared. Now, this last one you got to be careful about, okay? And the reason that I say that is, notice this was 24 and 24. This one, all the sides were 10. This one, all the sides were 4. All of these were regular. The reason that that's important is because the slant height is the same for every single triangle in each of these 3 shapes. But look at this one. We've got the slant height that goes from the vertex to the side of that is 7, and then the slant height that goes from the vertex to the side is 8. They're not the same. So this is where you have to have an understanding of what you're doing to find your lateral area. So what we're doing is your lateral area is your 4 triangles. There are 4 sides of the base. And so so let me go in and just highlight the base to make it stand out. Pyramids are really hard to see drawn in 2 dimension. Okay, so there's our base. So we can see the triangles. So I have 2 triangles. I have one that has a base of 10 and a height of 7, and I have one that has a base of 7 and a height of 8, right? I have this one right here with a base of 10 and a height of 8, and I have one right here that has a base of 7 and a height of 8. And there are 2 of those, right? The front and the back. are 10 and 7, and the right and the left are 7 by 8. So I find the area of the triangle. So this is 1/2 of 10 times 7. So the area of this triangle is 35. And the area of this triangle, 1/2, the base times the height, that's 56 divided by 2, which is 28. So I have 2 of these triangles, right? So that's times 2. And I have 2 of these triangles, so that's times 2. So 70 plus 56 is 126. So you cannot use the formula on this problem because your slant height is different. It was the same on all the other problems, but 1/2 PL won't work because you have 2 different slant heights. Okay, and then we've got to do our total surface area, so we take that lateral area, 126, that's your 4 triangles, and you add the base. Well, the base is a rectangle. So the area of a rectangle is 10 times 7, base times height. So 126 plus 70 is 196. And that is square feet. And that's square feet also. So that is a pyramid. It works for regular pyramids. Just understand your lateral area is your triangles, and then you've got to add the one base. With a prism, we added 2 bases because there were 2 bases, but there's only one base for a pyramid. So let's look at our cones. They are on your formula chart. If you look right here, pi RL is your lateral area. That's the cone part, like a paper cup. And then your total area would be pi RL plus pi R squared. That adds the circle. So now you've got a cup with a lid on it. Okay, so my lateral area is pi times the radius times the slant height. And that goes from your vertex to the edge. And then your total surface area is your paper cup, right? That's your piece right here, because the net for a cone looks kind of like this. And so your lateral surface area gets you this piece, which is your cone, right, that with no top on it. And then your total surface area is your cone, but it actually has a solid top. So plus pi R squared, because you're going to add the circle. So if I want the lateral and surface area of the cone below, lateral area is pi RL. Total or surface area is pi RL plus pi R squared. So look at my problem, and I already have an issue. I don't have my radius. This is missing, but that's okay. We have this little right triangle because the height and the slant height form a right triangle. So I can do Pythagorean theorem, r squared plus 12 squared is equal to 13 squared. Subtract 12 squared from both sides and you get r squared is equal to 25. Take the square root of both sides and you get that r is 5. So my radius is 5. That's also a 5, 12, 13 if you know your triples, your Pythagorean triples. So pi RL, lateral area. So my lateral area is equal to pi times r times L. And pi times 5 times 13 is 204.2, and that's meters squared. Now, pi RL, so pi times r times L plus pi times r squared. Now you notice before I just wrote the whatever I used, right? When I did this before, I just used my my lateral area again, and the reason I could do that is because there weren't a lot of decimals, but there are actually a whole lot of decimals, and with circles you want to carry the whole thing out. So when you're doing the surface area of a cone, go ahead and retype all of this out. Type all of this in your calculator so that the decimals don't mess you up and you get the wrong answer because of your decimals. So pi times 5 times 13, that's where this is kind of handy to have that's 65 pi, then you could just do that right there. But plus pi times 5 squared is 282.7 meters squared. Okay, so it says to find the slant height, that's L, of a cone. Okay, so here's what we've got. Here's my cone. Dotted line for the back. We have our height, we have our radius, and we have our slant height. If it has a surface area, so as soon as you see surface area, you go to your formula chart, you find your surface area. So surface area is equal to pi RL plus pi r squared. So surface area is 822.78 is equal to pi times the radius. It says you have a diameter of 18. That means you have a radius of 9. And then L plus pi times r, which was 9 squared. So we plug everything in. Notice there's an L right there. So we're just going to do the math that we can do. 822.78 is equal to, I'm going to do this 9 times pi. 9 times pi is 28.27. There are 2 decimals here, so I'm going to keep 2 decimals here. Plus, L, I forgot the L. And then plus, and type in pi times 9 squared, and you get 254.47. Again, 2 decimals, so keep 2 decimals. It's that significant digit thing. Then we need to solve for L, so I'm going to subtract 254.47 from both sides. That gives me 568.31 is equal to 28.27 L, right? Then divide both sides by 28.27, and you get that L is equal to 20.1. So the slant height is 20.1 for a cone that has a surface area of 822.78. And that would be centimeters because it's a length. Okay, so again, everything goes back to the formulas. Know how to use your formula chart, but then also know what each piece represents. The lateral area is the sides of it, and then your total surface area includes your base.